Okay, today our topic is GTO. GTO means gate turn off thyristor. Okay, so GTO symbol is anode, cathode, and gate. Okay, so this is the GTO symbol. Okay, so next, principle of operation of GTO. So you have to explain principle of operation of principle by using this circuit. Okay, so the basic operation of GTO is same as that of the conventional thyristor. So the principle is difference lie in the modification in the structure to achieve the gate turn off capability. Okay, so the principle of operation of GTO will be explained by using this circuit. Okay, here we are taking the PNP and NPN, PNP and NPN. So these are connected like this. Okay, so here the GTO, the current will be flowing from PNP to and NPN. Okay, so the firing angle alpha 1 plus alpha 2 is just a little larger than the critical value of 1. So short distance from gate to cathode makes it possible to drive a current out of a gate. Okay, so here the alpha angle alpha, and so the firing angle of alpha 2 will be larger than alpha 1. Okay, so next, TRIAC. So TRIAC means triode for a alternating current. Okay, so TRIAC is a 5-layer device that is able to pass the current. Actually SAR is 4-layer device, but here TRIAC will be 5-layer device that is able to pass the current bidirectionally and therefore behaves as an AC power control device. The main connections are simply named main terminal MT1 and the main terminal M2 MT2. So the gate designation still applies and it is still used. It was with the SCR. Okay, so here track will be bidirectionally. The current will be passing and it behaves as a AC power control device. Okay, so the main connections are simply named as main terminal 1 and main terminal 2. Okay, so and next, so track condition. Okay, it is not only carries a current in either direction, but the gate trigger pulse can either polarity regardless of the polarity of main applied voltage. The gate can inject either free electrons or holes into the body of TRIAC to triggering condition either way. So track is referred as 4-quadrant device. Okay, so track is used in an environment. So we are using a track in AC environment. So it will always turning off when the applied voltage reaches to 0 at the end of the current at off cycle. Okay, so the turn on pulse is applied at the same controllable point. After the start of each half cycle, we can directly control what percentage of that half cycle gets applied to the load. Okay, which is typically connected in series with MT2. So used for light dimmer controls and motor speed control. So track will be used in AC environment. Okay, so it will always turning off when the applied voltage reaches to 0. So thyristor will be turned on when applied voltage will be 0. So at the end of current half cycle. Okay, so if a turn on pulse is applied some controllable point after the start of each half cycle, we can directly control what is the percentage of that half cycle gets applied to the load. So it will be connected in series. So actually in track will be used in light dimmer control and motor speed control. Okay, so this is the track symbol. So it will consist of 2 terminals. So MT1 and MT2 and this will be gate. Okay, so here we are seeing the symbol of track. So this is structure. How you can connect the track? So actually track will be 4-layer device. Okay, so MT1, MT2 and gate here 4 layer. So first layer will be N and next P, and next N, and next P. So NP, NP, and NP, NP. Okay, so it is track will be 4 layer, and next will be snubber circuit. So snubber circuit purpose and design and working we have to studying. Okay. So snubber circuit is a circuit consisting of a series combination of resistance and capacitance in parallel with SCR. Okay. So this article describes the purpose, design and working principle of snubber circuit in details. Okay. So purpose of snubber circuit means the main purpose of snubber circuit is to prevent the unwanted triggering of SCR or thyristor due to high rate of rise of voltage such that dV by dt. We are already know that if the rate of rise of anode to cathode voltage of SCR high, then it may lead to false triggering. This is commonly known as dV by dt triggering. Thus, we need to have some arrangement to protect the SCR from such undesirable turning off application of snubber circuit, preventing from the such a suppressed triggering of SCR. Thus, it is basically dV by dt protection of SCR. So, snubber circuit why we are using means to control unwanted triggering. Okay, so here actually we have to protect the dV by dt triggering of SCR. We are using snubber circuit. Okay. So design and working principle of snubber circuit. So here, as we need to limit the rate of rise of anode to cathode voltage of SCR during its turn-on process, this means we should use a capacitor, because of a capacitor limits the rate of rise of voltage, whereas inductor limits the rate of rise of current. Thus, the capacitor when connected across the SCR terminals, when it limit the dV by dt. Let us now connect the capacitor across the SCR terminal and see how affect the dV by dt triggering. Okay, here this is thyristor. We are connected a capacitor. So thyristor, the capacitor will be connected across this thyristor. So here we are providing a switch. So whenever switch will be closed, the thyristor current will be going goes like to the load, and here so the thyristor and capacitor, the loop will be formed. Actually capacitor limits the rate of rise of voltage. Okay. So next, as we can see, we have connected capacitor C in parallel with the SCR. When switch SC is closed, a sudden voltage appear across the circuit. Initially, the capacitor C behaves like a shorted path, and hence voltage across SCR is 0. But as time passes, voltage starts building up across a capacitor with a slow rate. Thus the rate of rise of voltage dV by dt across SCR terminal will also be slow and less than the specified dV by dt rating of SCR. So at start, initially the capacitor behaves like a shorted path, and hence voltage across SCR is 0. But as the time passes, voltage starts building up across a capacitor C with a slow rate. So thus the rate of rise of voltage dV by dt across the SCR terminal will also be slow and less than specified dV by rating. So the dV by dt rating will be controlled by using the capacitors are connected parallel with the SCR. Sorry, across the SCR. Okay. So here we have to see in diagram. So here we have provided a switch and the SCR. So we have a capacitor will be connected. Whenever switch will be closing, at starting the capacitor will not run. So the voltage across the SCR will be 0, and whenever when switch some time will be passing, so the capacitor will run. So here some loop will be formed, and so the rating of a voltage changes with a time will be controlled. Okay. So, but above circuit design has one problem. Let us go to deep into above circuit to make improvement. Okay, as we can see, before the SCR is fired or triggered by applying the gate pulse, the capacitor C is fully charged up to supply voltage Vs. As soon as SCR is turned on by a gate pulse, this is charged capacitor C and discharges through the SR. Hence, current having a magnitude Vs and resistance of loop is formed by the SR and capacitor C. So, flows in the local path formed by the SR and the capacitor C. Since the value of resistance of this local path is quite small, the magnitude of discharging current will be quite higher. This will lead to high value of di/dt, which may exceed the specified di/dt rating of SCR. In order to limit the magnitude of discharging current, a resistance should be connected in series with a capacitor. This is shown in below. So, here we are connected capacitor across the SCR. So, whenever we have given supply, so this capacitor will be fully charged with the supply voltage and discharged by the SCR. Okay, due to this the current it will lead to high value of di/dt, which may exceed the specified di/dt rating of SR. So, in order to limit the magnitude of discharging current, a resistance should be connected in series with a capacitor. So here we have to, so the resistance will be connected in series with a capacitor. So we have limited di, so we have to limited the discharging current di/dt rating. Okay. So the above circuit. So the above circuit is the actual snubber circuit. There is a snubber circuit comprises of series combination of resistance and capacitance in parallel with the SCR or thyristor. Generally, resistance and capacitance and load parameters are so chosen that the dV/dt rate during the charging of capacitor C is less than the specified dV/dt rating of SCR, and the discharges the current at the turn on of SCR is less than the specified di/dt rating. Normally, resistance capacitors are load parameter forms an underdamped circuit, so that dV/dt is limited to acceptable value as provided by the SCR rating. Okay. So this is our topic today. So today we discussed GTO, TRIAC and SNUBBER circuit. Okay. So TRIAC will be 4-layer devices. Okay. So TRIAC will be 4-layer devices, and here SNUBBER circuit. Why you use SNUBBER circuit means to control the dV/dt rating. Okay. To control dV/dt rating, we are using the SNUBBER circuit. Okay.